State and prove the Lagrange's theorem statement. If P is a prime and f of x is equal to a n x raised to n a n minus 1 plus a n minus 1 x raised to n minus 1 plus so on plus a1 x plus a0 where an does not equal to 0 modulo p is a polynomial of degree n is greater than equal to 1 with the integral coefficients, then the congruence of f of x is congruent to 0 modulo p has at most n incongruent solutions of modulo p. Proof. Let us prove the theorem by induction on n. The degree of f of x, if n is equal to 1, the polynomial is a of the form f of x is equal to a1 x plus a0. Since greatest common divisor a1 p a and a1 and p is 1, then by the theorem congruence ax plus b modulo n has solution if only if d divides b, where d is a greatest common divisor of a and n, and if d divides b, then it has d mutually incongruent solutions of the modulo n. The congruence a1x is congruent to a minus a0 modulo p has a unique solution modulo p. Thus the theorem holds for n equal to 1. Now let us assume that the theorem is true for the polynomial of degree k minus 1, and let us consider the case in which f of x has degree k. Either the congruence f of x is 0 modulo p has no solution, or it has at least one solution. If f of x is 0 modulo p has no solution, then we are done. Let a be the solution of this congruence. If f of x is divided by x minus a, then f of x is equal to x minus a into qx plus r. Equation 1, where qx is a polynomial of degree k minus 1 with the integral coefficient and r is the integer. Putting x is equal to a in 1, then we get 0. F of is congruent to f of a is equal to a minus a into qa plus r is equal to r modulo p. So f of x is congruent to x minus a qx modulo p. If b is another one incongruent solution of f of x 0 modulo p, then 0 is congruent to f of b is congruent to b minus a qb modulo p. Since b minus a does not equal to 0 modulo p, then from 2 we have q of b is congruent to 0 modulo p, dividing both sides by b minus a. If in the other words any solution of f of x congruent to 0 modulo p that is different from a must satisfy q of x is congruent to 0 modulo p that is different modulo p by our induction assumptions that later incongruence can possess at most k minus 1 incongruent solutions. Therefore f of x is congruent to 0 modulo p has no more than k incongruent solutions.